Okay, so this is 7.1. This section, there's not a lot to say there's not a lot of conceptual things to explain. Basically, this is where you get to practice using all of the identities that you know, like the Pythagorean identity, or this is one of the Pythagorean identities, the other two being, and these are all listed, let's see, tangent squared, x plus 1, oops, wait a second, 1 over, this should be cosecant squared x, this one is secant squared x. These are all listed on the first page of section 7.1 in the textbook, and then you've got the reciprocal identities. Cosecant x is equal to 1 over sine x, and secant x is 1 over cosine x, tangent x. This isn't a reciprocal identity, but this is how tangent is defined, sine over cosine, and then you have cotangent, which is cosine over sine. And let's see what else. Then there's the, probably won't use this a lot, but cosine of a negative input is just cosine of that input. Cosine absorbs negative values because it's an even function, and sine is an odd function, so we can pull negatives. If we input a negative, we can pull that negative sign all the way out of sine. Like this, and that actually works for tangent as well, because tangent is an odd function as well. This is basically it. Am I missing any? There are some other ones. There are surely more trig identities, but this is pretty much what we're going to need for this entire section. So basically what we're going to be doing is just simplifying a bunch of trig expressions and proving trig identities. So an expression doesn't have an equal sign, and an identity is just an equation that's true for all values of x, or whatever the input value is. So these are all identities. So some techniques for proving these identities and simplifying these expressions. It takes, I feel like the best thing is really just to practice a lot. That's why I'm going to do a whole lot of problems here. But some techniques that do get used a lot is write, so here I'll call this techniques. Write in terms of sine slash cosine. So you see a lot of these, cosecant, secant, tangent, cotangent, they can all be written in terms of sine or cosine. And sometimes it's helpful to get everything in terms of sine and cosine, because then we have more to work with there. Get common denominators. Sometimes we've got to use little algebra tricks, like getting a common denominator to make things happen. Factoring, maybe like factor out greatest common factor. I'll say factor out common terms. So those are some techniques that you're going to see me using a lot in these problems as I'm working them. And let's just get into it, because like I said, there's not really a lot to say about introducing this section. It's really just about practicing the problems. So I pulled these problems that I'm going to do from the textbook, and I'm just going to go through them, and you can pause this and work it out by yourself, and then compare answers. Okay, so number 3 is cosine t times tangent of t. Okay, so I'm going to go with my first technique here of writing everything in terms of sine and cosine. So I'm going to say this is equal to cosine t times sine t over cosine t. There's tangent. And then I see the cosines cancel. Oops. And I'm just left with sine of t. All right. So these aren't too bad. Oops. So cosine t times cosecant t. I'm going to do the same thing here. I'm going to say cosine t, leaving that one alone, writing cosecant as 1 over sine. 1 over sine. And then that is the same as cosine t over sine t. And that is the same as cotangent. Cosine over sine is cotangent. Let's see, I'm going to write number 5 over here. Sine times secant, sine of theta times secant theta. That'll be equal to sine of theta times 1 over cosine theta. And that's the same as, so sine over cosine here is going to be tangent theta. So you see how here 4 and 5 they're basically the same, except they're upside down, right? This is cosine and cosecant. This is sine and secant. So this one was cotangent. This one was tangent. I'm going to start skipping steps like this. So here I went from cosine times 1 over sine, and I wrote out the next step, which would be cosine over sine, and then cotangent. But here, I just went ahead and said sine times 1 over cosine. Well, that's the same as sine over cosine. I just said it verbally, and then that is equal to tangent. And you're going to have to start, you have to skip steps like that, because these problems later on, they're going to get really long, and they will take forever if you write out every single little step. Tangent of theta times cosecant of theta is the next one. If I write everything in terms of sine and cosine, I'm going to have sine theta over cosine theta times 1 over, so cosecant 1 over sine theta. You can see the sines will cancel here, and I'm going to end up with 1 over cosine theta. Sine and sine cancel, but 1 over cosine theta is secant theta. Number 7, tangent squared x minus secant squared x. So far writing everything in terms of sine and cosine has been a good technique. It's worked for all of these so far, but this one, when you start seeing squared stuff and they're added or subtracted together, you should be thinking of these Pythagorean identities. And in fact, I see that if I reorganize this Pythagorean identity with tangent and secant, I can actually say that if I subtract secant from both sides, and then move this 1 across the equal sign, I'll have tangent squared x minus secant squared x is equal to -1. Just by subtracting 1 from both sides and then subtracting this secant squared across the equal sign, I end up with a new, it's the same identity, it's just been reorganized. But this is exactly what I have right here. So this is just -1. And that's it. That's it for that one. That's just one of the Pythagorean identities that's been reorganized. Let's see, number 8. Number 8 says secant x over cosecant x. So if I want to write these in terms of sine and cosine, the first one will be 1 over cosine x, and then over, that's this fraction bar, and then cosecant is 1 over cosecant is 1 over sine x. Now this is equal to 1 over cosine x times sine x over 1. Right, remember when you're dividing fractions, you keep the first one, change the division to multiplication, and flip the second fraction. And working horizontally now, because I'm out of room, this is going to be sine over cosine, right? This is just sine over cosine, which is tangent x. Alright, number 9. I'm not going to work every single one of these. I'm going to start skipping around later, but I feel like these first dozen or so, or maybe first 20, are pretty important because they set up some of these techniques that you need for the later, more complicated problems. Alright, so now we have an addition, and we don't have any squared things going on, so let's see what we can do with this. If we write everything in terms of sine and cosine, I'll have sine of u plus cotangent of u is cosine over sine. This is an interesting one. So now I have sine of u plus cosine squared of u over sine of u. Cosine times cosine. This cosine's in the top, right, with the other cosine. That's why it's squared there. Now this is one of those times where I've written everything in terms of sine and cosine, but what else can I do? Well, I can use one of those techniques that I wrote back here, getting a common denominator. So I can write this as, if my common denominator is going to be sine of u, then I'll need to multiply this by sine of u, and I end up with sine of u squared plus cosine of u squared. Or I should say sine squared of u plus cosine squared of u. If I say cosine of u squared, that makes it sound like we're doing this. That's not the same, so I misspoke. Okay, but now this is a Pythagorean identity, right? Sine squared plus cosine squared is just 1 over, or well, the top is just 1 by the Pythagorean identities, and then 1 over sine is just cosecant of u. Alright. Number 10 says cosine squared of theta times 1 plus tangent squared of theta. Okay, so I'm seeing squared things, so I'm probably, I should be thinking about these Pythagorean identities, and in fact, I see that tangent squared plus 1 is equal to secant squared. That's what I have here. I have tangent squared plus 1, or I have 1 plus tangent squared, but that's the same thing. So this is actually going to be equal to cosine squared of theta, cosine squared theta times secant squared theta, because this whole sum here turns into secant squared, but secant squared is the same as 1 over cosine squared. It's the same as 1 over cosine squared, so this just ends up being 1. They cancel each other out. Alright, number 11. Secant theta minus cosine theta over sine theta. Okay. Let's see. I think we should write everything in terms of sine and cosine. In other words, write secant theta as 1 over cosine theta minus cosine theta all over sine theta. Okay, and then we can see, there's multiple ways to do each one of these, and I can't promise that I'm always going to find the fastest way. One thing I'm thinking of doing is getting a common denominator in the top, similarly to how we did whichever number that was. But one thing we could do is also we could pull this fraction apart and write it as 1 over cosine theta over sine theta, and then cosine theta over sine theta. So 2 different ways of doing it. I think I'm going to go with the first way, though, of getting a common denominator of cosine theta in the numerator up here. So this is going to be 1 minus cosine squared theta. So I'm getting a common denominator between these two, and just carrying that sine theta over in the bottom. But 1 minus cosine squared theta is equal to sine squared theta by the Pythagorean identities. So I have sine squared theta replacing this over cosine theta, and then that's over sine theta. And this is the same as sine squared theta over cosine theta times 1 over sine theta. There we go. So the times 1 over sine theta, that's this happening. This division by this sine theta is the same as times 1 over sine theta. And then that is sine theta over cosine theta. Because sine squared and sine theta cancel each other with one left in the top. Whoops. And then we're getting tangent theta. Getting tangent theta there. Okay. Number 12 says cotangent theta over cosecant theta minus sine theta. I think I'm going to start working horizontally just to save some space. Okay, this is an interesting one. We've got a difference in the denominator here. Let's write everything in terms of sine and cosine and see if that helps. So in the top, I'm going to have cosine theta over sine theta over cosecant is 1 over sine theta minus sine theta. So this looks like a mess. I think we should write it as cosine theta over sine theta times 1 over that denominator. So all I've done here is just rewrite this division bar as times 1 over this. And then I'm thinking of, this has been a recurring technique here of writing 1 over something minus something, getting a common denominator, and it often works out for us. So let's see what we get there. We're going to have 1 minus sine squared theta over sine theta. Okay, and then getting a little bit weird here, cosine theta over, sometimes the algebra with the fractions gets a little bit weird, but multiplying by this 1 divided by all of this, that's going to be the same as, this is going to be the same as 1 minus, no, darn, sine theta over 1 minus sine squared theta. 1 over some fraction like a over b is equal to b over a. That has nothing to do with anything going on over here. It's just when you have 1 over a fraction, that's the same as that same fraction just flipped upside down. So that's all I've done here is I flipped this upside down. And now I'm going to end up with cosine theta over 1 minus sine squared theta. Oh, I was going to work horizontally. That's okay. And 1 minus sine squared theta, that's the same as cosine squared theta by the Pythagorean identity. By the way, back here, I canceled these signs, and then I just multiplied this fraction together to get this. And then 1 minus sine squared is cosine squared, and then finally this is 1 over, well, not finally yet, but almost finally, this is 1 over cosine theta, and that is secant theta. Okay, number 13 says sine x times secant x over tangent x. That's going to be the same as let's see, sine x times 1 over cosine x times cosine x over sine x. So I did a lot there. I changed secant x to 1 over cosine x. And then instead of writing over sine x over cosine x, since the tangent's in the bottom, I just went ahead and wrote that as times cosine over sine. So I'm saying that 1 over tangent x is equal to cosine over sine. So instead of writing all of this over tangent x, I just said times cosine over sine. And you can see how that's going to make my life a lot easier here, because I'm going to see a lot of things canceling. I've got a cosine and a cosine and a sine and a sine, and this all just works out to be 1. Everything cancels. Alright. Number 14 says cosine x times secant x over tangent x. So very similar to this one, except the sign has been changed to cosine. Oh, nope, I wrote it down wrong. It's supposed to be cosine x, where are we? Secant x over cotangent x. So it's actually a little bit different. Yeah. Okay, so I'm going to do a similar thing, similar technique here, writing cosine x and then 1 over cosine x times, now cotangent, 1 over cotangent will end up being sine x over cosine x. So that's just saying that 1 over cotangent of x, 1 over cotangent will be sine x over cosine x. And then I'm going to have some cancellation of cosine and cosine, and I'll just be left with sine over cosine, which is tangent x. Which is tangent x. Okay. Number 15 is sine of t plus tangent t over tangent t. That's going to be equal to sine of t plus sine of t over cosine t times, now if I'm writing, since there's a plus here and I want to write my 1 over tangent as cosine over sine like I've been doing, but there's a plus in the numerator, so I need to wrap in parentheses, and this is going to be cosine t over sine t. Okay. And I can actually distribute this in, and I'll have cosine t times sine of t. The signs will cancel, and I'll just be left with cosine of t. So this times that leaves me with cosine t. Plus, let's see, cosine of t, sine of t times this. That'll just be 1. Everything will cancel. That seems a little weird. Okay, that's it. Cosine t plus 1. And there's nothing else we can do with that. Alright, number 16 is 1 plus cotangent of a over cosecant of a. Okay, so this is going to be the same as 1 plus cotangent of a times 1 over cosecant. 1 over cosecant will be sine of a, because cosecant is 1 over sine, so 1 over cosecant of a will be sine of a. I wonder, did I write this down right? Cosecant. Yes, and then cotangent is going to be cosine of a over sine of a, and times sine of a, there we go. And then distributing the sine of a in, we're going to have sine of a, that's sine of a times 1, plus cosine of a. Sine of a times this, the signs cancel, and we're just left with cosine. Okay. number 17. 17 is cosine cubed x plus sine squared x times cosine x. Okay, so this one seems a little strange. I see some squared things, but also a cubed thing, so I'm thinking, how could I'm thinking of the Pythagorean identities, but how do I get that involved? And I think one thing that I'm going to try is factoring out a common factor of cosine. So if I factor cosine out, then I'll be left with cosine squared x plus sine squared x, and there it is. Because cosine squared plus sine squared is just 1, so I'm left with cosine times 1, which is just cosine. Okay. Alright, now I'm going to start jumping around a little bit. Let's see. 20 is secant x minus cosine x over tangent x. That's going to be 1 over cosine x minus cosine x times cosine x over sine x. It's the 1 over tangent coming in, cosine over sine. And then if I could get a common denominator in here, but I think I'm going to go ahead and distribute this in. I think that's going to clean up things faster. So if I distribute this in, I'll have cosine over sine times 1 over cosine. So the cosines will cancel, sine will be left in the bottom. So I've got 1 over sine x minus, and then right here, cosine over sine times cosine. That's going to be cosine squared x over sine x. And that will be equal to 1 minus cosine squared x over sine x. They already have a common denominator, so I can push them together. But 1 minus cosine squared x is sine squared x. And there we go. We're going to see one of these signs will cancel, and I'll be left with a single sign of x. Okay, 1 plus cosine y over 1 plus secant y. So this is a strange one. Let's see, what could I do here? Let me write it as 1 plus cosine y times 1 plus 1 over cosine y. Okay, so what I did there is I wrote this fraction as a multiplication problem. Oh, wait a second. No, I didn't. No, I did. Whoops, there we go. This is all supposed to be in fraction. So all I've done in these in this one step is wrote the numerator times 1 over the denominator, and I went ahead and changed secant to 1 over cosine. So far it looks worse. I've almost made it look worse. But what I can do now, I want to be able to flip this, right? That's what I want to do. That's like what I did with tangent here. I took my denominator and I multiplied by it, and I went ahead and flipped it. That's what I want to do with this, but the problem is I've got this sum here. So what I need to do is get this condensed into one fraction with one denominator, and then I'll be able to flip. So I'm going to say 1 plus cosine y, that's still the numerator, times 1 over, and then getting a common denominator here, I'm going to have cosine y plus 1 over cosine y. So I'm getting a common denominator here. 1 is going to be cosine over cosine, so my common denominator is cosine here. Now I can say, well, this is 1 over this fraction. So now I can write it as, now I can flip it and say cosine y plus 1. This is an interesting one. So I got my common denominator, or here I got my common denominator, so now I can flip 1 over this fraction is the same as the fraction upside down. And now you can see that this and this are going to cancel, right? 1 plus cosine is the same as cosine plus 1. So those are going to cancel, just leaving me with cosine y. They only cancel because they're exactly the same. That was a good one. That's an interesting one. 21. 23 is 1 plus sine u over cosine u plus cosine u over 1 plus sine u. So it's tempting to just cross-cancel here, but these are attached with addition, not multiplication. So we can't just cross-cancel things. We can get a common denominator, though. Common denominator is going to be the product of these two, so cosine u times 1 plus sine u. Okay, there's my common denominator, the product of these two. That means this one, which already had the cosine u under it, is going to need to be multiplied by 1 plus sine u. So I'm going to have 1 plus sine u times 1 plus sine u. And then this one already had 1 plus sine u under it, so it needs to get multiplied by cosine u. So I'm getting cosine squared of u. Okay, now I'm going to multiply this out, 1 plus sine u times 1 plus sine u. That's going to give me 1 plus 2 sine u plus sine squared of u. There we go, plus cosine squared u. There's that last term there. All over still this big denominator. So I got this from foiling out, from distributing 1 times 1 is 1, 1 times sine is sine, sine times 1 is another sine, that's why I have 2 sine u, and then the last term being sine times sine, which is sine squared. Okay. Now, sine squared plus cosine squared is 1, so I've got 1 plus 2 sine u plus 1, these both just turn into a 1, over cosine u times 1 plus sine u. Then I'm going to have 2 plus 2 sine u. So all I did there was add 1 plus 1. Okay. Then I'm going to factor a 2 out of the top, so I'm going to have 2 times 1 plus sine u over cosine u, 1 plus sine u. So I factored this 2 out, leaving me with a 1 plus 1 sine u, and then you'll see the 1 plus sine u factors are going to cancel, leaving me with 2 over cosine u, and I'm almost done. That's the same as 2 times 1 over cosine u. Right, this is the same as 2 times 1 over cosine u, but 1 over cosine u is secant, so I'm going to have 2 times secant of u. Yep, with problems where, especially where you have addition or subtraction in the denominator of a fraction, you've got to get pretty creative with the algebra. Okay. Next one is 26. This looks like another interesting one. Cotangent of a minus 1 over 1 plus tangent of negative a. Okay, so first thing I'm saying is this. Negative a in there. But I remember that tangent is an odd function, so I can have cotangent of a minus 1 over 1 minus tangent of a. I guess I don't need the parentheses now. That minus sign coming out of the tangent. And then I'm going to write this as cotangent of a minus 1 times 1 over 1 minus tangent of a. I need to get a oh wait, was this the best thing to do? Was this the best thing to do? Let's see, what can I do here? Oh yeah, write things in terms of sine and cosine. So cosine of A over sine of A minus 1 times 1 over 1 minus sine of A over cosine of A. So all I've done is rewrite this cotangent and tangent in terms of sines and cosines. Now I need to get a common denominator here so that I can then flip this fraction. So I'm just going to carry this along, cosine of A over sine of A minus 1 times 1 over, let's see, my common denominator down here will be cosine of A, meaning this needs to turn into a cosine of A, and then minus sine of A. Okay. And now I can flip this fraction upside down, so I'll say cosine of A over sine of A minus 1 times, yes, there we go, okay, times cosine of A over cosine of A minus sine of A, flipping this fraction. And now I need to probably get a common denominator over here. It's going to give me, my common denominator will be sine of A, and I'll have cosine of A minus sine of A times cosine of A over cosine of A minus sine of A. There we go. Now you can see how this and this are going to cancel, leaving me with just cosine of A over sine of A, which is cotangent of A. So this turned into just cotangent of A. Okay, now I'm moving into the identities, or with the equation, the equality. So cosine of x over secant x sine x is supposed to be equal to cosecant x minus sine of x. The idea with these is to just carry down the equal sign and work both sides. You don't have to work them at the same time. Some people like to just pick one side, work with it, pick the other side, work with it, and just get them to look the same at some point. The way I like to do it is I like to try and work both sides at the same time. I feel like that gets me there quicker, instead of working one side and then working the other. So I have no idea, I have no plan in mind for what these things are going to end up equaling in the end. So let's see. Cosine over secant times sine. Well, secant, let's see, what have I got here? Cosine of x over 1 over cosine of x times sine of x. This is equal to 1 over sine of x minus sine of x. Okay, so far I've just written everything in terms of sines and cosines. Now, cosine of x, this is going to be the same as cosine of x times cosine of x over sine of x. Because in the bottom here I have sine over cosine, but it's in the denominator, so that's going to turn into cosine over sine. Over here I'm going to get a common denominator of sine of x, and say 1 minus sine x, sine squared of x. Now I'm going to say on this side, cosine times cosine is cosine squared of x over sine of x. And 1 minus sine squared, though, is also cosine squared x. And there we go. That's all we have to do. We just have to get them to look the same. And you won't have an idea of what they should look like. Like, we had no idea this was going to turn into this in particular. In fact, there's other ways to get there to be equality between these two, depending on how you work it. The more complicated the problem, the more ways to get there. Like for this one, there's probably not that many ways to show that these are equal. Most of the techniques are probably going to lead to this relationship, but as the problems get more complicated, there are more ways to handle them. By the way, you're going to see this notation for left-hand side and right-hand side. So the idea is that this left-hand side turned into this, and this right-hand side turned into this, and I'm working them simultaneously to get the left-hand side to look exactly the same as the right-hand side. That's the idea. Okay. Right here I've got a sine over cosine for tangent, so that's sine over cosine over 1 over sine, that's the cosecant. And then on this side I've got secant of y is 1 over sine. Alright. Let's say this. And draw a little arrow and work the new equation over here. You don't want to put an equal sign in between here because you might get mixed up with the actual equal sign in your problem. So this left-hand side is going to turn into sine of y over cosine of y times 1 over sine y, but I'm multiplying, so it's going to be sine y. And this is going to equal, I'm going to get a common denominator here of sine, and that's going to give me 1 minus cosine y times sine y. Wait a second. This doesn't seem right. Oh, yeah. Secant is 1 over cosine y. So this is supposed to be, oh yeah, I messed this side up. This side should be, common denominator is cosine y, and I should get 1 minus cosine squared of y. Whoops. Okay, now I'm going to say sine, on the left-hand side, sine times sine over cosine, so I get sine squared y over cosine y, equal to this, but 1 minus cosine squared is the same as sine squared by the Pythagorean identity. And there we go. So this one worked actually very similarly in the end to the other one, to the previous one. Okay. Let's try number 33. Cosine of u times secant of u over tangent of u is equal to no. Where am I? Cotangent of u. Okay. Alright, so working both sides, the left-hand side is going to be cosine of u times 1 over cosine of u over sine of u cosine u. And then cotangent is cosine u over sine u. Now, up top here, I'm just going to have a 1. And since I'm dividing by sine over cosine, this is going to be the same as 1 times cosine u over sine u. But that's it, really. That's all I need. Not much to this one. Not much to it. So cosine and times 1 over cosine canceled. They cancel each other, just become a 1. And then I have divided by sine over cosine. That's going to turn into times cosine over sine. But that's exactly what's going on the right-hand side. Some of these, you will have one side working down more than the other, and sometimes you're forced to work with only one side if you are just not given that much at all. Like this one. Number 34 says cotangent x times secant x over cosecant x needs to equal 1. I can't really work with this much, so I'm probably just going to carry that along. I mean, what can I do with 1? I can say it's sine over sine, or cosine over cosine, or cotangent over cotangent. But without knowing what this side is going to work down to, I really can't do much with this. So I'm just going to carry it along and hope that this simplifies down to match it. Cotangent times secant. Alright, so here's my fraction bar. Cotangent is cosine over sine times secant is 1 over cosine. And cosecant is 1 over sine. Alright, so it looks like a mess, but let's see what happens. Cosine and cosine cancel, and I'm going to have in the top 1 over sine x. 1 over sine x, because cosine and cosine cancel. Then I'm going to flip this fraction and multiply instead of dividing by it. So I'm just going to have sine x over 1, but that works. That works, because everything cancels and I'm just left with 1. Alright, how about, where's 35? I need more room for 35. Number 35 says tangent of y over cosecant of y is equal to 1 over cosine y minus 1 over secant y. Okay. So this is interesting. Somehow this division over here turns into a difference. So that's kind of interesting. On the left-hand side, I'm going to have sine of y over cosine y all over 1 over sine y. And then over here, I will have 1 over cosine y minus 1 over cosine y. Okay. Now, on the left-hand side, I'm going to have sine of y over cosine y times sine of y. Times sine of y. Over here, I'm going to have 1 over cosine y minus cosine y. Because 1 over a fraction, remember, means you flip the fraction. Okay. This is giving me sine squared y over cosine y on the left-hand side. Over here, I'm going to get a common denominator of cosine y. That's going to give me 1 minus cosine squared y. We've used that technique a few times. But there we go, we're done. I'm not going to do anything to the left-hand side because I can see where this right-hand side is going. 1 minus cosine squared is the same as sine squared. And there we go. There we go. These are kind of fun. 35. Let's go to 40. Number 40 says sine of x plus cosine of x all squared is equal to 1 plus 2 sine x cosine x. Not much we can do with this right-hand side, really. Because we don't have any identities right now about a product of these two things. We will later, but right now we don't. So how would I multiply this out? What am I going to get? I'm going to get sine squared of x plus, this is like this identity, a plus b all squared is equal to a squared plus 2ab plus b squared from 112. It's going to be the same thing here, except sine is playing the role of a and cosine is playing the role of b. So I'm going to have sine squared plus 2 sine x cosine x plus cosine squared x. But what is sine squared plus cosine squared? That's just 1. So I end up with 1 plus 2 sine x cosine x. And we have equality. Alright, number 50 says cotangent squared t minus cosine squared t should be equal to cotangent squared t times cosine squared. Oh, that's interesting. The difference of these two, cotangent squared and cosine squared, is equal to the product of the same two things. That's interesting. Alright, what can we do here? Definitely thinking of some Pythagorean identities. So cotangent squared, where are my Pythagorean identities? Cotangent squared should be equal to cosecant squared minus 1. I'll subtract the 1 over. Is that what I want to do, though? I didn't work every single one of these out, so I may not have the best plan. Let's just do it. Let's see what happens. So cotangent squared should be equal to cosecant squared minus 1. That's this. And then minus, oh, I guess I didn't need those parentheses, but I will need them around cosine squared, because cosine squared should be equal to 1 minus sine squared t. Okay, and then this side, what can I do with this side? I can say cotangent is the same as cosine squared t over sine squared t times cosine squared t. Alright. Now over here, I'm going to have cosecant squared minus 1, and then minus 1, and then plus sine squared. So I'm going to have cosecant squared x, negative 1, and then another negative 1 makes negative 2, and then it's going to be plus sine squared. Oh, was it x or t? Oh, this should be t. This should be t. Alright, over here I've got there's got to be a way. Let's see. We can do, let's see, cosecant squared. Let's leave this side alone. And let's see about messing with this side. Let's get everything in terms of sine and cosine. So over here, cosecant squared t is the same as 1 over sine squared. There we go. That's looking better. And then 1 second. I feel like I messed up the Pythagorean identity. Nope, that was it. And then cosine squared is 1 minus sine. Okay. I'm worried about that 2. Where's that 2 going to go? It should have canceled out. Okay, so let's just keep going. We've got minus 2 plus sine squared. But sine squared of t is equal to sine squared of t is equal to 1 minus cosine squared t. Over here, I'm still just leaving this alone. Cosine squared over sine squared times cosine squared. Oh, I went about this a weird way. Let's see. There's got to be a better way. Okay. I'm going to have 1 over sine squared t, and then negative 2 plus 1 is negative 1, and then minus cosine squared t. Pull the negative out. No. Okay, I've decided that it's going to be best to start over with that one because I have a different idea and I think it's going to work better. Okay, sometimes they're a little tricky and you gotta try them a couple times. Cotangent squared t minus cosine squared t equals cotangent squared t times cosine squared t. Alright, first let's get everything in terms of sines and cosines. So this is going to be cosine squared t over sine squared t minus cosine squared t, and this side is cosine squared t. There we go. Alright, let's get a common denominator on this side. That's going to be a good idea, I think. Sine squared t is the common denominator, so I'm going to have cosine squared t minus cosine squared t times sine squared t. And this is equal to cosine to the fourth. Cosine squared times cosine squared is cosine to the fourth. And then sine squared t. And over here, what am I going to do? I'm going to replace one of these, cosines or sine squared, with one of my Pythagorean identities. Or actually, easier thing to do. Factor out cosine squared t, leaving me with 1 minus sine squared t, all over sine squared t. And I'm not messing with the right-hand side. There we go, and now there it is, because 1 minus sine squared is actually the same as cosine squared. So I end up with cosine squared t times cosine squared t over sine squared t is equal to cosine to the fourth. And of course these are equal, because cosine squared times cosine squared is equal to cosine to the fourth. There we go. That was a tricky one. Alright, just a couple more. One more identity, and then one more, or two more slightly different problems. 1 plus secant squared x over 1 plus tangent squared x is equal to 1 plus cosine squared x. Definitely thinking about identities here, Pythagorean identities, because I have that 1 plus tangent squared is secant squared, so I can say 1 plus secant squared x over secant squared x. And how about I just leave this one alone, because I have a feeling we're going to want to leave that one alone. Now, how about I split this fraction? It's got a common denominator, but what if I split it apart? 1 over secant squared x plus 1, right? Secant squared over secant squared is 1. But 1 over secant squared is cosine squared. And there we go. Much easier than the last one. Alright, so the last two are problems where we are taking an expression in terms of x and replacing x with a trig function. And by the way, theta is bounded into the first quadrant here. This is just to, okay, why does theta needed to be bounded in the first quadrant? We don't want this to end up being negative, and that's basically why. Because in some of these problems, if it was negative, we could end up with a negative under the square root, and we don't want that. Okay, so if x is sine theta, directly substituting, I'm getting sine of theta over square root of 1 minus sine theta squared, sine squared of theta. But that's the same as 1 minus sine squared is cosine squared. But square root of cosine squared is going to be just cosine. And that's just tangent of theta. I suppose we also need theta to be bounded just so we don't run into any issues with the trig functions themselves. Alright, here's another one. Let me get another sheet for this one. Alright, last one, 92. 1 over x squared times 4 plus x squared, where x is 2 tangent of theta. You actually do run into problems like these in calculus when you're doing calculus things with trig functions and functions like this. You go back and forth between substituting things like this, and you find yourself having to simplify things just like this with trig functions plugged into them. So I want to square x. So that's going to give me 4 tangent squared theta on the outside. That's the x squared on the outside. I've got a 4 because I squared the 2 as well. And now inside I'm going to have a 4, that 4, and then plus x squared is 4 tangent squared theta. Okay, and then that's going to be 1 over 4 tangent squared theta times square root of, factor that 4 inside out, leaving me with 1 plus tangent squared theta. So factoring the 4 from this and this, leaving it under the radical though. Okay, and now that 4 will be coming out of the radical eventually. Now I've got 1 over 4 tangent squared theta, that's just carrying along on the outside. 1 plus tangent squared theta on the inside though, that's equal to secant squared. So I've got 4 times secant squared theta. But now everything under here is a perfect square. So I'm getting 1 over 4 tangent squared theta times 2 secant theta. Applying the square root there, taking the square root of 4 and secant squared. And then, yeah, I guess we can write everything in terms of sine and cosines, just to do any last canceling that we can do. 4 times 2 is 8. Tangent squared is sine squared over cosine squared, and then times 1, secant is 1 over cosine theta. So we end up with 1 over 8 times sine squared theta over cosine cubed theta, and that's the same as 1 over 8 times cosine cubed theta over sine squared theta. Maybe it would be better to write this as back in terms of cotangent, maybe 1 over 8 times cosine theta cotangent theta. Because cosine squared over sine squared is cotangent, but I've got cosine cubed, that's why there's an extra cosine there. Okay, so that should cover pretty much every kind of problem that you might come across in section 7.1. And that is really all there is to this section, just working a lot of problems, just practicing these techniques, and that's it.